So the first thing we want to do is select the compass tool from the toolbox and create a circle in the center of the page. Now using the segment tool, go from the center of the circle to the edge of the circle and make another segment from the center of the circle past the edge of the circle. Now select the text tool and label the endpoints of the segments A, B, and C. Still using the segment tool, create a segment from endpoint A to segment BC, somewhere in between point B and the edge of the circle. Now using the text tool, we click this intersection point and label it D. The next step is to reflect triangle ABD over segment BC, which acts as our mirror in the kaleidoscope. So we use the arrow tool to highlight segment BC by double-clicking until those boxes appear, highlighting segment AD and segment AB. Next, go to Transform in the drop-down menu and click Reflect. This process of reflection needs to be completed multiple times. Again, we double-click this segment, highlighting it, highlight this segment, and segment BC, go to Transform and Reflect. Done is reflected the original triangle ABD 11 times over itself, and what we end up with is a bunch of triangles. Now if you click, hold, and drag point C, I'm dragging point C to the left, you can see that it moves all these triangles and creates a gap on the side. So what we want to do is line up these two segments, segment AB along with this other segment, as best we can. As you can see, a 6-point star has been created within the circle. Now, to change the look of the star, you can, using the arrow tool, select point D and drag it along segment BC, and you can see that the points of the star become more defined or less defined. So this is not really crucial, but can be set to however you like. With that set, the next step is to measure angle ABD. Do this by selecting the arrow tool, highlighting points A, B, D in order, going to measure in the drop-down menu and selecting angle. From this we can see that when angle ABD is 30 degrees, we have a 6-pointed star. Now going back to point C and dragging it to the right, we can create a 5-pointed star. And you can see that the angle of ABD is 36 degrees for a 5-point star. Again, dragging point C to the right, we can get a 4-pointed star. Line that up as best you can, and we can see that angle ABD is equal to 45 degrees. Upon further investigation of angle ABD and its relation to the points in the star, we can create a table that looks like this. In the right column on top, we can see that when angle ABD is equal to 90 degrees, we have a 2-pointed star. When we have a 3-pointed star, angle ABD is equal to 60 degrees. So in finding a star with n number of points, the formula for finding the degree of angle ABD is 180 degrees divided by n. When looking through a kaleidoscope, every portion of the image should be fluent. By that I mean that no breakages or seams in the image should be detected. To prevent seams or cracks from showing in the kaleidoscope, angle ABD must be a divisor of 180 that yields a whole number. When the angle between the mirrors, or angle ABD, is such, the points of the star line up, as you can see in this star. When angle ABD does not divide 180 degrees evenly, there can be breakages in the image, such as this on this 4-pointed star, or on this 6-pointed star there's a gap on the left side that you can see here. So in creating a kaleidoscope, this is one of the most important things to remember so that the image will always appear to be flawless.